So what's up with the Intel MKL if you're using a non-Intel processor? Is Intel intentionally trying to cause problems for AMD? Something rotten in Denmark? Well, that's a little more complicated than that. Let's try to talk through it. The Intel MKL is a math kernel library. That's what MKL stands for. It is a set of routines for doing math, certain kinds of math operations really quickly. And that probably means we're going to get a lot of terrible math jokes in this video, because what other opportunity would I have for doing terrible math jokes? These routines are optimized, highly optimized for running on Intel processors. Intel processors. I'll come back to that. x86 processors in general, but Intel processors is what they're optimized for. Because believe it or not, the different ways of doing math, some are faster on processors than others, depending on how you're actually executing it on silicon. And that is very interesting in a whole other world of crazy. I'm going to introduce you to some resources for people that are into that level of world of crazy in terms of how long does this instruction take to complete, because there's a lot more variables than you would think. I mean, in addition to the different instructions for doing different kinds of mathematical operations, and you break a large complicated mathematical operation into smaller pieces, there are other constraints, power constraints, because processors turbo until they reach a power limit or they reach a thermal limit, and different kinds of mathematical operations may cause the computer to throttle. So one math operation might be faster until the processor hits a certain thermal wall, and then another math operation becomes faster. And so if you're a researcher and you're running these things continuously, chances are turbo and stuff like that doesn't really matter much to you unless the processor can sustain those turbo frequencies for an extended period of time, because chances are whatever it is that you're doing fancy complicated math for is going to run for hours or days or weeks or months or years. Anyway, before I get off track, since time immemorial, there has been product segmentation from Intel on Intel processors. Going all the way back from before the Pentium. 486, there's SX and DX, and 386, SX and DX. There were different versions of the 286 as well, but the SX and DX denoted a different functionality that was available. Basically, do you want a math coprocessor? Even all the way back to the 8086 days, 8088 days, you could get a math coprocessor, like a physical chip that you would install, and then that would, offer you math functions. And then later, they sort of cheated a little bit. The math coprocessor would actually just shut off the main processor because it was cheaper and easier to just do everything on one processor than to try to shuttle things back and forth between the SX processor and then its 487DX math coprocessor. They would actually just shut off the 486 SX and then just do everything on the 486DX because the other option was more complicated. We have AVX 512. AVX 512, but there's like 74 different versions of AVX 512, which has really been a large part of its uptake problem. And AVX 512 also has some of the thermal and power constraints, like I was talking about, at least on Skylake, but to a lesser extent, that's not as true as it once was on Cascade Lake on the server, but then do people really need that on the desktop? There's a lot of little tendrils in this conversation that is related to the modern parts of computer science that really keep me excited, because at the end of the day, all you need to know about me is that I'm a computer janitor, but I really actually enjoy solving the puzzles. To me, the blue screen, why doesn't this work, is a Holmesian mystery that if I'm not careful, I'm going to get sucked into and figuring it out, because the answer is usually really interesting. And so we have, the mob maybe is grabbing their torches and pitchforks a little bit because they're looking at this Intel MKL thing. So the Intel math kernel library, their stated mission is, their goal is to be the best performing math library, period. And this is even something that they'll say in answer on the math kernel library forums, because there's a large community using these Intel tools. Intel employs a huge number of very brilliant software developers. Intel is doing a lot of really cool, amazing stuff with their software and their integration, more so than just their processors, more so than any kind of fabrication or process problems that they may be having, any kind of uptake problems they may have with AVX 512. But from a computer science standpoint, AVX 512 is genuinely very exciting. And these really high performance CPUs from, literally everybody. I mean, we've got ARM entering the picture. I've always been excited about the Marvell. IBM open power stuff is sort of lurking in the background. All of this stuff is genuinely very, very exciting to me. But with the Intel Math Kernel Library, there was a workaround in 2019 that would say, just use AVX2 no matter what. Like, don't check the CPU, just use AVX2. And the AVX2 implementation on AMD Zen CPUs is actually quite good. It's shockingly good. It is giving Intel a run for its money, if we're really honest about the situation. And if you're a researcher or a computer scientist, believe it or not, helping some people with their PhDs and their research and, just doing the computer janitorial tasks for those brilliant folks, they super don't really want to play with things as much as I do. Holmesian mystery, it's like, no, we don't really care. It's like, it's stuck up again? Yeah, well, just, can you get it unstuck? So that's where I come in. And so you dig under the covers to find out why this is, because when Ryzen 2000 launched, the workaround was basically you could set an environment variable and just tell the Intel MKL, which is that version kind of was not really AMD aware, and so you could look at it and say, okay, the Intel wasn't really planning for this. You just tell it, no, just use AVX2, the AVX2 instruction set, get it done, and you can do it. And AVX2 is kind of like MMX, and kind of like the whole SX and DX thing, because in the beginning there was SX and DX, and then there was the Pentium, and then the Pentium with MMX multimedia extensions, and you could get it, with and without, and then you can only get it with MMX, and then there was SSE and SSE2, and these are all different instruction sets that have been added over the years, and there is still some product segmentation. I mean, even AMD has done it. It's like, I've got a Phenom 2. Yeah, sorry, you're not going to get very many vector instructions there. That's just it's not something that you get. Well, I mean, you get a little bit of stuff on the Phenom 2, but not much. And Intel with their Pentium and Celeron lines, they don't. Last I checked, I don't think they even enable AVX2 on those, which is that's 5 years on. I think that's a mistake, but it's what do I know? So we're in a situation where those AVX2 AMD instructions with that workaround work great. And so no matter what you're doing with this math library, I mean, it can be vector multiplication or fast Fourier transform or any kind of like really pretty high-end math. Well, I mean, that's linear algebra, but it's mostly linear algebra, but any kind of high-end math that a researcher is going to want to do, you can count on this library to look at what silicon you're running, figure it out, and go from there. So the rotten part is that it looks like this library pretty consistently is just looking at, are you Intel or are you not Intel? And if you're not Intel, then we're not going to bother to figure it out. But there are mechanisms in the processor to figure out what instruction sets are available. So you ask the processor, and it's like, okay, I've got AVX2, I've got AVX, I've got SSE, SSE2, SSE 3.1, SSE 4, I've got FMA, I've got FMA2, but not FMA3. FMA3, some of those instructions work, some of them don't. Let's just pretend FMA3 is not there. So the processor will tell you what it can do. And other competing libraries like OpenBLAS, Open Basic Linear Algebra System, which is a competing system for the Intel MKL, which is not quite as optimized, generally not quite as fast. It depends on what you do. Some things are okay. Some things you can sort of hand optimize it. But again, we're sort of back to that. Researchers don't really, they just want to hit a button and go. And that's really, like, companies have definitely exploited that for commercial gain, Intel and NVIDIA, which is not necessarily a bad thing if that's your business model. I mean, they make it easy and they can profit from that. I mean, that's fine. But, it is perhaps a little unsettling that instead of having stuff in the MKL that says what instruction sets are available, and it's instead saying, is this an Intel CPU? And there are some things that we can do, even though the old hack sort of worked. So last year, in 2019, you could just say, use AVX2 no matter what, with a debug symbol, and it would go on and it would use, like, say, the AVX2 code path, and that works great because AVX2 on Zen CPUs is genuinely great. It's genuinely awesome stuff. People notice the performance regression, about a 15 to 20% performance regression, not across the board, but with a lot of functions. in the 2020 update 1 from Intel, and we've just had 2020 update 2. And so I was looking through the changelog for 2020 update 1 and 2020 update 2, and it doesn't mention anything about AMD specific kernels or AMD specific code paths or changes or optimizations that have been made. I'm looking at this, and it really does look like the Intel team is building Zen specific code paths that can actually take advantage of Zen CPUs. So depending on what the function that you're running is, like SEGMM versus DEGMM, those new code pathways that are in update 2 are not awful. Like, they're okay, but it's still a fairly big difference, because like one of the bundled benchmarks with the MKL system will do about 370 gigaflops on a 2000 series Ryzen. I was able to confirm that. I saw some people on the internet do the same sort of testing, and you can squeeze a little bit more out of it with the Zen pathway. But if you use the old debug symbol workaround, that no longer works. It doesn't work the same way. And so we can't use an environment variable as workaround anymore. But Daniel, who is working as a researcher, has offered a clever workaround, which is basically the name of the function in the Intel MKL is Intel _serve Intel CPU true, and that returns 1 if it's an Intel CPU and 0 if it's not. So you just patch this executable to always return 1, and you're good to go. Now, if you're doing something with AVX 512, obviously that's not going to work, because AVX 512 on, an AMD CPU is not going to work, because AMD CPUs don't have AVX 512. But if you need to do a test to force the AVX2 code pathway, that works perfectly fine. And don't you know, if you do that and you run mt-sgemm to do your benchmark again, look at that. You're getting 800 gigaflops per second, 851, give or take, because you're actually going through the AVX2 code path once again. And so it's gotten a little harder to do the workaround with the Intel MKL, with the whole environment variable thing. And I also question this because it's checking to see if it's an Intel CPU, not what instruction set is supported. Again, the stated goal of Intel MKL is to be the best MKL possible. Intel is so large and has so many resources and so many brilliant PhD level people working for them. At this point, I refuse to believe that this is deliberate shenanigans, or at least this is deliberate shenanigans on the part of large swaths of Intel employees. This is probably bad timing or an oversight, and Intel will probably make a statement about this, because at least in research circles, this probably will have legs and will be carried by a lot of outlets. And that's one of the reasons that I'm doing a video on it, because it does look not great. The optics here are not the best for Intel, especially given some historical considerations. But the good news is that AMD actually does have some optimizations for Open Blast, or for BLAST, basically in your algebra system, and they have that on their webpage. And so I think AMD is aware that, hey, we need to have some tools that are readily available for researchers, and it needs to be push button and all this other kind of thing. In the past, people would say things like, this is a great product because it has mind share of the users already. So if you're working on a machine learning project, or a research project that needs crunching of numbers, and you go to your research committee or your PhD committee, and it's like, here's my idea, here's how I'm going to do this, and they ask you and they get into the details with you. If those people have mind share of the kinds of things that you're talking about, it's going to be easier to talk them into doing something. And I don't think that the Intel MKL has a particularly high mind share, just in that it is easy to use. It is very well put together. It is very well polished. Intel has a great and busy forum that goes with that, and there are a lot of people doing really cool stuff there. There's a lot of people doing they're talking about really interesting projects, and it's hard not to get lost there looking at all the interesting projects people are doing. Now, I will say that Intel, in doing all the work on the MKL, if they want it to be only for Intel processors, that's fine. Put that in the license agreement and be upfront about it. Don't do shenanigans with the the checks. But I think that Intel R&D is smart enough and forward-thinking enough that they really don't need to do those kind of tricks. And I would be surprised and disappointed if that's really what it is. So I think that we will see more stuff in the changelogs from Intel addressing this if we don't actually get some sort of direct response. If, on the other hand, if the new workaround, where you're literally patching the binary, stops working, then I'll do another video. And I think that it'll be much more interesting to talk about intent, like what was intended with those changes, because this is kind of like the 2019 to 2020 update. That's kind of a big update. It's possible that the environment variable just sort of fell out accidentally because of the new architecture, because it does look like this new architecture is going to be able to switch around CPUs a lot. And we know that Intel has major microarchitecture changes coming for their own processors down the road. And so these changes could be a result of Intel making changes preemptively, knowing that new microarchitecture and like new silicon, like we saw the tiles thing with the Intel Xe stuff. But at the same time, you really have to trust but verify, or verify the crap out of it. And even though some of this is not fully open, although most of it's open source enough, the internet is a much different place than it was even 5 or 10 years ago. And so with communities like ours, like you're watching this video and you're putting this together, we will be able to supervise the situation and lay bare to exactly what the situation is if it turns out to be something a little bit shady or something a little bit sideways. It's going to be really easy to diagnose that, and the optics of that, like I say, would be much worse. And so I really doubt that that is what's going to come to fruition here. That said, it's also possible for AMD to benefit from all of the work being done in this space. If Intel's stated goal here is true, that this should be the best math library that's available, then this new modular architecture that allows Zen kernels will allow open source scientists and researchers, even people on AMD's own team, to contribute to the project with their own kernel, potentially. Maybe that's a little pie in the sky, maybe that's a little wishful thinking, but certainly if not, there's OpenBlast. And OpenBlast, with a few $1 million of funding and some really smart PhDs at the helm, it's not going to be an issue. For now, when you run the benchmarks, just out of the box though, with MKL, you should be aware that if you're running on a Zen processor, so like Threadripper or Zen Ryzen 2000, Ryzen 3000, Ryzen 4000, you're probably not getting the performance that you should unless you jump through some hoops to, patch some stuff. If you have a compiled binary that you don't have the source to, that's okay. There's a utility called patchelf, and that's, what Daniel DK mentions in his blog post here. You can use patchelf to literally add a library that has an override function that will override that Intel check, and it'll always just return true. That would certainly be useful for diagnostic purposes, if nothing else, but there could be side effects if your binary depends on, say, AVX 512. In general, a program should check instruction sets, not the type of CPU, because, AVX 512, it's probably going to turn out to be safe with AVX 512. Like, I keep going back to that, but for this video, I actually struggled to find an example where that worked, because every program that actually implements AVX 512 explicitly checks for AVX 512. So in addition to running this, they also do the AVX 512 check, which is kind of hilarious, because I think if Intel hadn't segmented the market so badly with AVX 512, that they probably wouldn't have done that. It's like, oh, it's an Intel CPU, oh, it's got AVX 512, we can count on that. But because you can't, and because there's so many different versions of AVX 512, at least for this math library, in addition to checking to see if is it an Intel CPU, the programs that incorporate this library also check for AVX 512. So you can have an Intel CPU that doesn't have AVX 512, which is not as uncommon as you would think that it is. And because of that, AMD CPUs continue to work correctly, because, oh, you've got AVX2, but you don't have AVX 512. Oh, you're one of those Intel CPUs, and the AMD CPU's over the corner. Yes, that is exactly correct. That everything is fine. Nothing is on fire. Well, this is level 1. Hopefully this is not too long of a ramble. I had some fun putting this together, and you should check out the stuff on the the Intel website, because there's a lot of good stuff there, and the discussion forums and stuff. All right, I'm signing out, and I'll see you later. So you want to do really fast linear algebra? What do you call a baby eigensheet? Oh, a lamb, duh. I like the pandemic version of that joke a lot better, which is, what do you get when you cross a mountain goat with a mosquito? Well, you can't, because that's crossing a scalar with a vector. See ya.